All right, students. So this question is from the topic of mechanics. Excellent question if you want to understand momentum. Don't forget to subscribe to this channel. You will find some excellent playlist of class 11, 12. And the level is going to be simple, medium, and complexity, depending on the type of exam you're taking. Let's get going on this problem. Now, this is a bullet. Okay, this is a bullet that comes and strikes a block of mass capital M. It embeds inside the block, and then together they move up by a height h. You can see the question, read the question carefully, then I will start solving it. Okay, and we will not only solve it, we will go for detailed explanation as to what exactly is happening. So it reaches the height h. Question is, what was the initial velocity of the bullet? Okay, so we have to go backwards, right? In terms of the system uh, going up, from there on, can we encode something? Can we decode something? Sorry, right. So let's start solving that. I hope you have read this question now, and let's see what happens now. Already, so when you enter, right, as a bullet, when you enter the block, your initial momentum, right? And why do I apply momentum? Because I see motion, I see mass and velocity, and therefore I think about momentum, right? So the initial momentum is because of the bullet, right? So the bullet is in motion, and this is the momentum of the bullet. That's your momentum of the bullet. With this momentum, it walks inside the block, okay, and therefore transfers the whole momentum to the block and becomes part of the block. So that means block will now acquire a velocity and then start moving up. So the final momentum will be m plus m and the velocity of the combined masses. I didn't see any external force, nothing. I was not carried away by the idea of kinetic energy to start with. That's a next level thinking whenever we think of kinetic energy. Can we use kinetic energy here, right? A lot of people would argue that this is half mv squared. So why is that you did not transfer the kinetic energy to the kinetic energy of the block? The reason is when this embeds inside, right, there might be a loss of energy. So I did not go on that direction where kinetic energy conservation is to be applied, because when the bullet enters, it will enter and some work will be done against the friction with the block. So the easiest approach was that my initial momentum is this, my final momentum is this. If I struggle here, maybe I would have gone ahead and thought about kinetic energy, stuff like that, but not now. I'm just worried about how much there is no external force, momentum needs to be conserved. And therefore, Ti, okay, Ti is equal to P. So M into V1 is equal to M plus M. And this is V combined mass. So now we know what is V combined mass. We'll just use a short. So this is M into V1 upon M plus M. This is your V combined mass. So now the block moves up with a combined mass of M plus M, and it moves up. Okay, so it reaches here. Okay, so when the combined masses M plus it embeds here. Okay, let me show you that state of the system. So now the mass is M plus M, and the bullet is inside the block. At this point, this is the combined velocity, right? So we know the combined velocity. Now the combined block moves like this, right? And therefore, the kinetic energy which is there, you can see there is a gain in height. which means what? Whatever is the kinetic energy here, which is half m plus m v squared, and we know the v square, this is the kinetic energy here, gets converted into potential energy at this point. Right? So this is a bullet which is embedded, raised by a height h along with the block. The total potential energy is this. So let's cut this off. Okay, so this goes off, and therefore, what are you left with? So I will take the 2 on the other side. So m v1 squared upon m plus m half m v squared, right? So half m v squared. This is equal to 2gh. I have taken this 2 to the other side, and now v1 squared is equal to 2gh m plus m upon m. All right, so now this becomes, right, it was a square, and therefore v1 is equal to under root of 2gh m plus m upon m. This is a correct answer. So you can see the choice number, I think the choice number is A, right? The first choice matches with this. So I hope you understand. So what did you notice? There was a law of conservation of momentum being applied there. After that, the law of conservation of energy was used. The kinetic energy got converted into potential energy. Most of the confusion is if this, couldn't we apply kinetic energy concept here, that the kinetic energy of the bullet is half m v1 square and is equal to the kinetic energy of the combined mass. No, you cannot. Remember, they stick with each other. What is the use case for sticking, right? There is loss of energy. Two masses coalesce, right? They enter into each other. There's a loss of energy. You should be aware of this. Therefore, I did not go that path. A lot of students do that and get confused. Very good question. If you want to see how in one question the law of conservation of momentum and then law of conservation of energy get applied simultaneously and in one go. So thank you very much for watching this video. Please don't forget to subscribe to this channel. You will see some fantastic numericals coming your way for your upcoming examination. Thank you very much.